All right, last thing we got here is our reflection. It says, what were the big ideas in this unit? Answer in detail, please. Big ideas were things like, well, of course, linear equations and systems. We needed to know standard form. We need to know slope, intercept, form. We needed to know the equal values method. We need to know the substitution method. We needed to know the elimination method. Of course, standard form is, of course, ax plus by is equal to c. Slope-intercept form is, of course, y equals mx plus b. Equal values method is good for 2 slope-intercept form equations. Just put that in parentheses to show that that's when you use it. Substitution method is good for 1. It's good for 1 slope-intercept form and 1 standard form. So yeah, it's, you know, when you have 1 slope-intercept and 1 standard, yeah, that's what you're doing. You're doing substitution method, and the elimination is when you have, of course, 2 standard form. Those are probably the biggest ideas. So other things is that a solution to a system is where the lines intersect. Other things, if the lines do not intersect, they are parallel. And this would be no solution. And that would be like, you know, all variables cancel and there's a false statement. That means that, you know, those two equations can never be true at the same time. Just like 2 lines can never be in the same place at the same time if they're parallel. Okay, and then of course, if 2 lines are the same, then the solution is all real numbers. And that would be like the same as all variables cancel. The only difference is that's if all the variables cancel, you're able to eliminate them all. But instead of getting a false statement, you get a true statement. So I would say, yeah, these are a series of lessons to be learned. I don't mind if you take this one just verbatim from me, because honestly, this is solid, concise lessons to be taken away. One last thing we can say is that all variables can be isolated, and any multi-variable equation can be rewritten from the irrespective of a different variable. So, the example is, force is equal to mass times acceleration, and that's true. But if we were to divide by acceleration, you could also say that it's force divided by acceleration equals mass. So now if you wanted to do it in terms of mass, you say mass equals force divided by acceleration. Equally true. That's actually a really huge thing, especially in your science classes, especially like physics. You're going to do this all the time. So really important learning right there. Okay, thank you very much. Congratulations, and onward and upward.